So, hello everyone. Welcome to the Integrate workshop. My name is Etienne. For those of you I don't know yet, I'm the Technical Support Director at Robotiq. I've been around for 6 years now, a little bit more. I did start as an intern, then a production engineer, switched a little bit to R&D, and I took off tech support 3 years ago. And of course, at tech support, I was involved in a lot of integration case. A lot of them were going wrong, of course. So people call me when things are not as smooth as expected. So I build up quite an experience with that, with you guys' questions mostly. So today's workshop is really about Integrate. We'll do a 45 minutes presentation. I have a guest with me. We'll speak about his testimonial and then we'll take questions. We'll also have our CTO, Jean-Philippe, will be there to take questions on plug-and-play components and project development. So you have a good panel for your questions, and we'll try to get as much as possible out of this. So, so my pointer is not working anymore. Too bad. So Integrate is really at the heart of the cell deployment. Sam explained it a lot this morning. I won't go too much into about why it is such a challenge and everything like that. You were introduced with this logo this morning. This is really the sum of everything that Robotiq will be doing. You were all given the Lean Robotiq book in your earlier workshop. You will learn about the lean robotics within that. And basically, this logo is everything Robotiq will be doing for you. Basically, Blueprint attends the design stage, skills, plug-and-play component, and DOF are for integration. You know DOF, it was introduced last year. You know us for the plug-and-play component, of course. And now, today, we're introducing skills. And your next workshop, Operate, will focus on insights. So yes, integration is a challenge. I was thinking about how I could explain all that, how the stories I could tell you about how things can go wrong during an integration, and why everything you can face and why it can be so tough. But instead I found someone I've met during my travels will speak about his experience, who's probably one of the biggest I've seen. So I will let Adam come in and introduce himself. Go ahead.
All right, like you said, my name's Adam Beachy. A little bit about me before I get started. I am 22 years old. I am currently a junior at Illinois State University getting my bachelor's in engineering technology. I also have my associate's degree in electronic control systems, and I'm also recently engaged. That's why it was last. So, my experience. You're probably all wondering why I'm up here. This past August, I finished a 1.5-year-long internship at Hydrogear in Sullivan, Illinois, where we built a new assembly line and integrated 32 universal robots onto one assembly line, along with roughly 20 to 25 Robotiq grippers as well, and a couple of force torque sensors. So I have a lot of experience with the universal robots and the Robotiq grippers as well. So the challenge that we faced when we first started the project was incredibly high employee turnover rate. We bring in employees every single day and train them, and then new employees would leave the next day. We were constantly hiring new employees, and we couldn't keep up at all. Another challenge we had was we had a really high demand for this one model product, and we were running 3 shifts a day, 5 days a week, producing about 400 to 450 units each shift, and we still couldn't keep up. So we had to do something. So the solution. A normal assembly line, to give you a little context, had 25% automation and 75% manual. So the solution we came up with was we're going to flip that, and that's where the 32 universal robots came in. We use the the UR robots and the Robotiq grippers because of the functionality they bring and the plug and play and all of the features that have come along with that. So here's a sample of two of our stations we had. This is one of the more complex stations we had. It's a lot of parts here. The black fixtures you can see there, that's where the operators would grab a handful of parts and load those fixtures, and then the robots would come in and take the part out of the fixture and place it either on the unit or into an assembly fixture to do more work with it. As you can see, there's no sensors at all in those fixtures. We relied heavily on the object detect feature and the RQ position of the gripper to determine if there was a part and if it was the correct part. If it was the wrong part, it would either leave it there or stick it into a suspect part bin and move on. So this is one of the more complex stations, but all the different models we had, that's what we came up with. Here's another example of two stations. As you can see here, we mounted you kind of see it there, a DC Stanley torque tool on the left robot along with a Robotiq gripper. This allowed us to pick a bolt, start the thread with the robot, and then use this torque tool to torque it down to a specific amount. Actually, we were really successful with that. We were pleasantly surprised with how well that worked. So some of the challenges we faced was the part picking. We had to come up with a way to fixture the parts in such a way that the robot could pick all of them and then place them in the several different orientations they would go in. So we came up with those fixtures. This allowed us to design the fixture so that it would only accept one part. So that would be part of our airproof, cuts down a whole bunch of sensors we would normally have. And then we used the gripper of the robot to further airproof, make sure it picked the correct part and it didn't drop the part along the way. Another challenge that we faced was the part variation. We quickly found out that our parts are not very well constrained in the design, so they can vary a lot dimensionally. And we found that there was a lot of variation in some of the parts that caused the robots to not be able to place them correctly. And we went back and looked at it and figured out that part of the problem was the fixtures we designed weren't toleranced correctly, and then part of it was the actual parts were coming from the suppliers out of spec. So that was a huge challenge we had to face and take care of before we could move on. Probably one of the biggest things for us was standardizing the programs. Trying to keep all 32 robot programs similar. It was a huge task that I was lucky enough to get. And so about probably halfway through the project, or 3/4 of the way, we found a good way to have a good template that would work on every single robot with minor tweaks here and there. And the reason we wanted a standard program was so I'm not there anymore, so that one of the other engineers could come in and be like, they could learn this one program and then go to every single robot down the line and see that, okay, this is why we're doing this way, and this is this, and all that. It makes it a whole lot easier for troubleshooting. It helped me too, because I could quickly go through it much faster, and then it helped other engineers and other maintenance to come in and be like, okay, I learned how to do this on another robot. I can see why it's doing this and what I need to fix. Cycle time. I don't think I touched on this earlier, but the goal was to have a 20-second cycle time per station. So a normal assembly line had roughly 45 to 50 seconds, and this was producing about 400 to 450 units a shift. And our goal was to get 1,000 units per shift. In order to do that, we had to get our cycle time down to 20 seconds per station. This is a challenge because 20-second cycle time is not very long, and the assembly process is very complex. A lot of parts go into it, and we had to figure out ways to break up the process so that each robot only had a few tasks to do so they could do it much faster. By the time I left, we were down to about 40-second cycle times. Obviously not where we wanted to be, but we had a functioning assembly line, and by that point, it was what we needed to do to get product off the line. They were set up in a position to where in the coming months they would make changes, design changes to get that cycle time down to closer to 20 seconds. That's the goal. Reliability related to the pallets that we had our units placed on. We manufactured hydrostatic transmissions for zero-turn mowers, and the housing gets put onto a pallet, and we found that the reliability of those pallets to the dimensions we had sent to the machine shop were, some of them were very far out of spec, so this caused positional problems and reliability with the robots picking and placing parts accurately and causing lots of frustration and headaches. And I kind of mentioned earlier, the complex assembly process. This was something we spent a good probably month and a half working on, figuring out how we're going to split up this massive process that's incredibly complex with parts that are not made for a robotic operation. How we're going to do that with robots and do that in the time cycle time we had. So we came up with splitting up the stations into what we thought would be 20-second cycles, and then we went from there. So this complex process that would take people using their vision, their hands, their feel, and everything, we broke that up so that the process was much simpler for each station, and that allowed us to get, in theory, down there 20-second cycles. So in summary, integrating one robot, I'm sure, has all kinds of challenges and headaches that you face, but I kind of got thrown to the wolves and had that multiplied by 32, so plus going to class at the same time, so we had a lot of stress, but through all that, we figured out that the most crucial thing for integration that we found was the design process, which is pretty obvious, working through all of the possible problems that could come up during this time beforehand, so you eliminate all that stress and time waste and money waste. If those come up when you're actually integrating, you get that done beforehand, that eliminates a whole lot of stress. And also the standardizing the programs. Keeping things as standard as possible helps not only the programmer, but also helps other engineers that come in so that they can learn it much quicker and allows everyone to be on the same page much faster and allows everything to flow better. And that is all I have. Back to Etienne.
Thank you, Adam. So that was quite interesting, and you have probably understood why it is such a challenge to do integration. You did a massive project, in fact, the biggest I've seen with those 32 robots. They did a fairly good job with that. They were pushed back by a few months, but you were fairly on target. I've seen people with one robot that were pushed back a year, so that's good. That's very good. But most of our customers, or you guys, will be using 1, 2, 3 robots. Even with those small installations, you will still have challenges. Every time you install, every time you have to explain your customer how to install, they need to install, plug, they need to program the basics all over again. And that's mostly why we did plug and play projects, so that you can save time on those things. So even before we thought about lean robotics, we were already doing projects that were aligned with that. And on top of that, you have the application. So you need to program depending on your application. And the application is never as simple as the customer said. Most of the time you have things that pop up. And that's why before you start, you basically need to do your homework. Adam pointed out, what's the single most important thing before you do integration? You just walked out of it. It's the design. So you've seen in your earlier workshop that you should come up with something like that. So you would come up with normally 3 things before you go to integration. And you will do those 3 things tomorrow morning, by the way, during the challenge. First of all, you should have your process mapped. You should have the manual process mapped. You should have the Robotiq version mapped. So that's the first step, and that will be your high-level plan. You will do that tomorrow morning. We'll guide you through that. Second thing, you should have the cell layout before you start. Tomorrow you will be using equipment that's fixed, so you don't have to bother about that. I spent my whole summer planning the cell layout for you. In our case story that's within the book, you will see the CNC machine fading story, which use a cobot, a dual gripper. The dual gripper is picking up raw parts to feed the CNC machine, take the finished part, put the raw part, and then get the finished part out on a table. Well, that's a fairly simple application. Third thing you would come up with is really your robotized process. So that's really basically your robot program in a pseudocode format. So basically what task your robot will be doing, and that will be your detailed plan. So tomorrow when you get to do the challenge, before you start programming, you should have that on some kind of post-it, or we have giant post-it for you guys. And your program should be details in those steps, and that should be your the beginning of your program and the template you'll be using, basically. So you can use comments, you can use folders, use whatever you like, but normally you should have, before you start, all those tasks. So you start with the first thing is usually getting the part, and then moving to somewhere and sorting a part, something like that. You will be asked tomorrow to work in team of 12 people. You will be multiple people by robot, so you need to be able to take your teach pendant, give it to your partners, and he knows what's the program. So you need some kind of task subsections in your program, and it need to be identified. Of course, if you have just a list of 147 waypoints and you give that to someone, you cannot keep up with your work. So before you do the integration, we'll ask you, and you must do those simple steps to get a successful design, and then it will help you all along the integration. So let's assume you got that. Will you be ready to go? Tomorrow you will be ready to go. In real life, our customers, they have to choose. They have a tough choice to make. Sam explained it this morning. It's always a question, integration or doing it yourself. So most of our end user, they have to, if they are considering integration, that's mostly because they don't have the skills to do it by themselves. So that's why it's such a tough choice, because they have to spend money or spend time, and both are the same in the end. So either you learn by yourself, it takes weeks or months, or you pay someone who knows, but then you don't learn. So, and that's the statu quo Sam was speaking about this morning. And our solution to that is Lean Robotiq, on your own, not alone. So what's behind that fancy sentence? First of all, there were our plug-and-play project. And stacking on that, now we add the skills that we introduced this morning. So that's the example you've seen this morning. So what are skills? Skills will be functions that we will give you. So it's a set of free-to-use functions that are meant for our plug-and-play projects. They come by the way of a UR cap. You install that. There is no interface with that. You get only a function. So for those who are advanced with the UR, you know about scripting, and you know there's a function list, like the UR force mode, and there's a bunch of them. Now, when you install one skill, you will get in that function list, you will get the skill over there. So I will go through the details and you will understand, but we have a series of skills. You will find them in that function. And those skills, basically, they contain hundreds of lines of code within a single line. They are really meant for people who are beginner or intermediate. So the people we want to help with integration. And all of them are meant to be used with our plug-and-play component. So they are based either on just one of them or sometime on a combination of them. And the goal of all that is that you get our plug-and-play component that are really already easy to install, easy to program. You get the skills with that, and with that it becomes your toolbox, and you can do almost any kind of application. They will unlock the potential of your plug-and-play component. For example, you know that the two-finger gripper, you install it, it's quite simple. You have two wires to plug in, you install your UR cap. Then when you want to program, it's very easy. You have an interface, you have open, close gripper. That's easy to do. But then even if you can open and close a gripper, it doesn't mean you can actually do a CNC machine tending. You still need to know how to program, do relative motion if you use vision and all that. That can be quite complex for beginners. So with the skills now, they will be able to use those skills to do advanced programming for our projects. So it allows newbies to do a lot more. So how does it look like? You will have, that's the skills.robotiq.com website. You land over there. It's the same account as you will be using for Insights. So next workshop we'll be speaking about Insight. Same account to reach both things. When you reach that, you have a series of cards like that. Each of them is a skill. They all have very short names. You will see we are limited 22 characters for UR caps. So we have to be creative on how we name them. When you click on one of them, you will get the detailed view. So if I clicked on spiral search, I would end up with that. You would get, well, the description, of course. The download button will get you the UR cap you need to install to get the function. Then you have a short PDF for instructions on what it does and how it does it. And you have a video that shows you an example of what it will do. So in summary, why we did skills? We want to enable advanced programming to beginners to intermediate, so make programming accessible. Want people to save time, and it's free. So that's 3 very good reasons to get them. And our goal, of course, is just to accelerate the integration phase so that we, of course, end up selling more of our plug-and-play products. So an example of that. So you've seen this story in the earlier workshop. This is Acme. So there's a lot of place where we could put the skills to use. I usually start with the input. So for example, over there, we would use vision to pick parts. You know our camera. It's meant to be really plug and play, easy to use. You have seen the teaching interface. So that interface is meant for almost anyone to be able to teach. Either the original method was the automatic. So you've seen that. You scan an object, the robot scans it and learn the model. We have introduced not so long ago the parametric method, where you could input simple shapes, square, circles, rectangles, and teach them. Yeah, you like it? Yeah. So that's very useful. But then even when you're done with that, you need to know how to program, because you teach the part, very good, yeah, but then you still need to use the movell, relative motion, use reference features, and all that for someone who doesn't know the UR can be very confusing. So we did one UR cap to help those people. It's called the camera auto pick. This UR cap, the skills, will basically find the part from its center and automatically pick it. So it's meant to be used with our two-finger gripper, of course, so that we know the TCP. And then users can just use our RQ_autopick function, and that will pick a part from its center so that the user can just call that line and then move the robot one place to another. So you end up with a very simple program, and you don't have to know anything about relative motion, feature, reference frame, and all that. That's one example that could have been used. So that come from our case study with the Walt machine. I've seen Tommy over there. So Tommy would have liked that a few months ago, but that's available now. It's a very common application for machine tending when you have simple shapes like that out of aluminum or steel. So that first example. Then an example with our two-finger gripper. You know it for its flexibility and ease of use, but there are still some quite complex programming that you can do if you want, for example, to optimize cycle time. So in that case, normally you always want to optimize your cycle time. You never want to go slower than possible. So every time you pick, open or close on an object, you have to manually find what's the best way to pick the object, be as close as possible so that you don't waste time with the gripper fully closing onto an object, and instead you pick it as close as possible to cut down your cycle time. That skill will do that for you. So basically it's going to get you to open with as little as possible to release your part so that you reduce time with that. We did some tests. A normal opening for the gripper would take 1.5 seconds. When you use that, you cut down by almost 50%, so 0.8 seconds that you would reach. So that might sound very little, but in applications like Adams, where he was using, he was trying to reach 20 seconds, that can be very useful. And then when I have to explain people over the phone how to do that, it can be quite complex sometimes to tell them, okay, you have 0 to 255, that's our 8-bit encoders, and then you have to find out the sweet spot to open and close your gripper. Well, I don't have to explain that anymore. They will use the quick release function. No, that's not the Walt machine, but it's almost that. So that could have been used to find the sweet spot to release that part, for example. And now third, with the force torque sensor, which we barely see over there. Insertion in a chuck is quite common, or any kind of insertion. Tomorrow you will do an assembly, so you will have a lot of insertion tasks and orientation and all that. So those are really my favorite. That example is with the linear search. Linear search is basically seeking a part, so you're just going down until you touch a chuck. Our skill allows you to search in 3 directions. So basically the skill is a function. Remember, and function have input argument. That one, the argument is the direction. So you send x, y, z, and it's gonna search for a part in z and x and y, and automatically stop when it reaches it. So normally you would need to load our sensor template, which can be a little bit clunky with before start and a thread. It can be scary for people who don't know what's that. And then you have to program all your motion, do increments around the movement or speed with the robot. That's really advanced stuff. Now with that, you do that with a single line, and the user can use the force torque sensor effectively. You've seen that example this morning where you had this program with you see that's part of our template with the thread on the bottom. You see all the program to seek the part, do the increment. Now with the find function, it's like that. One thing missing over there, it should say RQ find X, RQ find Y, and RQ find Z, or the opposite, and then you would find all directions. So that's as simple as it can get, for now at least. So where is this going, the skills? We have 11 available today on the website. We will release each quarter. In fact, we'll try to release each 2 weeks. The integration coach, every time they work on an application for a customer, they try to recycle the program they do, package that in functionality, and put it online afterwards. So it will always be, alive, kept alive and going. It will always focus on our plug-and-play components. Today you have one that's an exception. We did one for conveyor control. So we got a sponsorship from QC Industries. They gave us conveyor, and you will have a skills to control that with like a simple function, RQ conveyor. You send the distance and it will move the conveyor to that distance. And if you have played with that, you know it's probably complex. So a lot of input, output, and things to configure to get that working. So that's another example. Second subject, the force torque sensor. You've seen the release this morning. We did announce a new updated version, so the name is not changing anything. We changed the hardware on the inside. On the outside, you won't see any difference. On the inside, we did a major electronic redesign. So you will end up with 10 times less noise. So those who know our sensor, you know about the noise spec we give. Noise is really the movement of your signal. So if you have 0 force, there will always be a little electrical noise. well, that noise can be a problem for high sensitivity application. It will be cut down by 10 times. Second thing we did is the robot-made calibration. So if you visit us, you'll see in our production floor that the force sensor were calibrated by hand before. Now we have UR robots, UR10, that will be doing the calibration so that we have much more accuracy on the calibration. Basically, we're putting mass on the force sensor in different orientation, and you record those values to do your calibration curves. That will be done by a robot now, so you have improved accuracy. As of today, I don't have the specs, but they are roughly the same order as the noise improvement. So the difference between noise and accuracy, noise is really movement around your value, and accuracy is how precise is your value. Yeah, we're trying to. So that's why I say improve accuracy and I don't give numbers. It's really hard to do that because we can give you very accurate specs on, for example, X and Y, like pure values. But when you go in between, it's very hard to spec. But we are working on that. And what we'll probably give in our spec sheet is load case. So we'll give you the expected accuracy in X and Y and Z in X with a certain lever. So we'll give you a few cases so that you can estimate roughly what's the accuracy in unknown direction. Of course, we cannot give you specs over the full, but we could, but then it would be quite a nightmare just to read it. You would need like big charts to find out what's the accuracy in a specific direction. We'll give you a simple case, and it's going to be ready. It was supposed to be ready last Friday. It will be in the coming days, basically. We won't be updating anything. It's a hardware change, and we started shipping last Thursday without telling people because it's just better anyway. But yeah, it's already out. So along with the hardware change, we are working also on a software update. You will have a new UR cap update for the force sensor, and that has a very huge potential. First little thing, we have embedded data acquisition, so that means that you don't need the template anymore. Variables will be like global variables, basically, so you don't need our clunky before start and thread to update the force torque sensor data. That's one nice thing, but the main thing is the UR force mode. We will be able to feed the UR force mode directly with the force sensor readings. So actually the force mode of the UR is using a complex algorithm to approximately know the force that is applied on it because the UR has no direct force sensing. They did a very nice job, but they are limited by it's basically maths that are doing the force calculation. With the force torque sensor, you will have the accuracy of the force torque sensor within the UR force mode. So that give you 0.5 Newton instead of 20 something Newtons that you could usually use with that. For those who know what's a Newton, just know that it's a lot better. That UR cap is still isn't beta right now. It's still in development. It will be released soon. Everybody will ask me how soon is soon. Should be this fall. We planned it in September, but then we ended up working too much on what you're doing tomorrow. So it's pushed back a few days, but it's upcoming. And of course, the skills will be for that. Almost finished. So that's the force mode of the UR that we will be feeding directly. So that's the list of the new capabilities. So we have, of course, with the more sensitive sensor, you will have better contact detection, weight measurement, and there would be a ton of example. The force control of the UR will be improved. Our active drive and path recording will be improved, of course, because of better sensitivity. Improved application, so those stuff we were already doing them. A lot of assembly application that we already were doing will just get better. Quality control data recording, you will record better data, of course. Now the interesting part, we will be able to do new applications that we couldn't do at least not easily before. So everything that's finishing, especially we get a lot of requests for polishing, grinding, deburring, all application that you need to keep contact and object, you need to keep pressure and you need to move. Those were quite challenging to do. Now they will be much easier to do, and we will help you with that with the integration coach. Quality control also, we will have, with the better sensitivity, a lot of applications will be unlocked. So some practical concerns. Part number is the same, project name is the same. We started shipping already. The skills are available. And we got this question earlier. All the software is retrocompatible. So if you have an old sensor, the new one, it doesn't change anything, and the new software will always be available on the older sensor. Yeah. Exactly, yeah. Yeah, you could try, but you will end up with very horrible result. If you try to do polishing with the actual sensor using the software we'll release and the upcoming skills, it probably just won't work at all, depending on what's your tool. Yeah. There will be one little visual display on the force sensor. We have patent technology, and now it's going to be written on it, IP .robotiq.com, patent pending, something like that. There's a very little visual difference. We'll communicate to our partners what's the serial number. So there's like a cut at some point, and from that and above, it will be the new force sensor, of course. And the UR cap is upcoming. Almost done. Tomorrow, during the challenge, you will have the old force sensor on the robots, but on stage we have 3-4 robots on which we will have the new force sensor. You can come and try it, see the difference in the active drive, the path recording, and all that. You should feel that quite easily. They will be on stage. You will have the integration coach and the UR tech support will be there, and next to them you will have robots with those new force sensor if you want to try them. We have time for questions. Yeah. So we'll be taking some more time for question. GP, our CTO, is joining me to answer everything about the plug and play product. Is really the specialist with the force sensor. If you have any questions for Adam with his very nice experience, and Adrian will walk with the mic so that we can all hear you when you got questions. So anyone want to start over there?
Where? Oh.
Yeah, you have.
Yeah. Coming.
Hello.
Yeah.
With this increased sensitivity, is there going to be any sort of certification available to get with these grippers now?
So I will answer to this question. Not for now on, but we are looking at it since we have many requests from partners about that. So we may come with something like that during fall. It is something we are looking at, but from the day we will ship, we won't have this. So I want to make a small correction, Etienne. We didn't start shipping last week. We will do
start this week.
This week or at the beginning of next one.
Okay.
So wrong Thursday.
Whoops. Sorry.
Does the hardware changes affect the IP rating of the FT300?
No, still the same. Still the same mechanical casing. Everything is the same for the moment. Only the electronics inside changes.
Still 100 hertz?
Yes.
So what's the difference? Because you only said it was spending more time, so
Yeah.
between the old and new one, what's the difference? Or it's only
You mean in terms of what's inside?
No.
In terms of for the customer?
No, you said it's 10 times more yield noise.
More sensitive for the noise. And for the accuracy, we're still waiting for the real numbers. So we'll come up with the numbers about the sensitivity, about the accuracy, I'm sorry. So this will come this week. We will have a new spec sheet with that as well. the most important stuff is what Etienne said, is improving the application we already did, and at the same time enabling new applications such as part finishing and those applications. So that's the main difference.
Other questions? No? I'll go
I
ahead.
think everybody can hear
Yeah.
me.
Yeah.
You mentioned that we will be able to tackle applications like sanding and polishing. Have you guys done any tests on sanding applications?
We have done some, but since we were working on the hardware first, we know that the force will be more accurate. The level of details will be done in the upcoming weeks, and for that you will need in fact you will need the new UR cap in order to do those applications. So this will come later on.
On the
Yes.
vision plug and play option, you mentioned there's some skills being developed for that.
Yep.
Other than part recognition, do you have plans on including barcode reading, something like that?
So
on
this
the data, on that type of data collection?
Yeah. So the question is, will there be more functionality to the UR cap of the vision? So right now we do vision locate, meaning the idea is we teach an object, and then the system will try to recognize position orientation of this object on a 2D surface. So short term, what we want to do is improve the precision and speed of what we have right now, and simplify the calibration methodology and simplify the use of it. This is short term. We want to come up with the new UR cap revision quite soon this fall. After that, we are looking at different kind of application, as you said, barcode reading and all of that. I won't tell you exactly what we are working right now, but it is to expect to have new, for instance, Node doing something else than vision locate right now.
Anybody else?
Oliver.
Adam, when you put this torque screw on there, and you're torquing the screw down, obviously it's going to pull the robot, so you have to put that in pre-drive?
We use the force mode. So whenever,
This one just go down.
yep, it would go on top, and then as soon as the tool started, it went into force mode until it was done, then it
Yeah.
turned off and went up.
Okay.
Yeah.
We have some stock of your old force sensor. Should we, I'm sure you're kind of dreading this question, but should we do something about that, or
Yeah.
like maybe, you know?
So here we are in a meeting with customers, partners, and everything. This will be discussed for the distributors with your CSM probably tomorrow morning or on specific meetings. So we will reach out to you for those details, but there's kind of a plan for that as well.
Yeah, fair enough.
Since we have customers and users, then we won't go into details about that here today.
All right, good.
Yes?
I have also a question for Adam with your monster project. Congratulations to get that done.
Thank you.
I was wondering, what was the main argument for you to use all these mechanical fixtures instead of the vision system from Robotiq?
The main reason we didn't use that, when we started the project, the vision system wasn't released yet. So we would have had to backtrack and redesign a whole lot of fixtures. So that's why we stuck with what we had for right now. The plan is for the future is different bowl feeding parts, presenting the parts like that, and then as well using the vision system.
Right.
I have another question for Adam. Can you describe how you standardized your programs? Like what kind of things did you standardize?
So what we did was every step of the process for each robot was its own program, and then we had a main program called the sub-programs up. Each program had a folder with all the moves and everything in it, and then named that folder accordingly. And then so when you called that in the main program, you could see what the folder was, what program you were calling. And we also, in the template main program, we had all of the variables that were the same across the board. Those were all declared in the before start and the comments, and also folders. So keep stuff like that, and then all the threads we needed, and then all the switch cases and if statements were all there already. So you just plug in, you basically just throw in all the stuff you need for that one robot, and you can see this is why we're doing this, because we did it over here, and so on.
Well done.
Yeah. And I suggest you remember that for tomorrow. You use folders for each of your case. Yeah. Right.
Just got one more. For your project, Adam, what was kind of the justification for having a collaborative robot versus just a standard robot?
In the beginning, the justification was we wanted the operators to work directly in the same space as the robot. So we were going to go with the URs because they're collaborative, so the person could walk in, place the part without fear of getting hurt. That was why we went with them originally. And after about a year and 2 months, we decided to go a different route, and we had someone almost get hurt by one of them. And it wasn't serious or anything, but the safety department wasn't very happy with that, so we just put light curtains in front of it, and we started treating it like a real industrial robot. Whenever they were in the same space, the robot stopped, and then when they exited, it picked up again. So that's why we went with that originally. We wanted to do it that way, to where there was no safeguarding at all besides the robot, but in the end, our safety department wasn't comfortable with that.
Right. One last question.
I know you already mentioned something that it's a hardware change, but you also mentioned the ability to use the force torque sensor values in the UR force mode.
Yes.
Is that dependent upon having new hardware as well, or is that capable to do with the old hardware?
No, it will be, it shall be compatible. It should be, I'm sorry, should. I will still have to be validated, but it should be. But I would not, the results would be less. So,
Understood, yes.
So, but it should be retro compatible if you have 3.1 revision of the UR.
All right. We'll let you go on your way for the next workshop, for the Operate workshop. It's in the plenary.